Hello, in this video, we're going to be looking at lesson 7.1 on ratios and proportions. Unit 7 is all about similarity, and part of similarity involves proportions. So we're going to spend some time on proportions here today so that we're able to apply them for the rest of chapter 7. The essential questions that we'll cover are how do you write and simplify ratios, and how do you solve problems using proportions. You've actually already done proportions before because we used proportions and cross products when we solved the sine, cosine, and tangent problems in Unit 8. Let's start with some vocabulary here. A ratio just compares two numbers by division. The ratio of two numbers A and B can be written in three different ways. It can be written as A to B, A colon B, or A over B. And all of these are the same. They're just different ways to express the ratio, but they all represent the same ratio. I'll give you an example with some numbers. So I could do, for example, 3 over 4 is a ratio, 3 colon 4 is a ratio, and 3 to 4 is also a ratio, and these are all the same. So they look different, but they all represent the same ratio. For our first example, we're going to look at how to write a ratio to represent the slope. You would have done this back in your algebra course. Recall that slope is just rise over run, where rise is the change in the y-coordinates and run is the change in the x-coordinates. So when we look at our 2 points in this picture, we're going to pick one point to be x1, y1. I'm going to just let this first point be x1, y1, and then the other point will go x2, y2. Calculating with the slope formula, now I can just take my numbers. So y2 minus y1 would be negative 2 minus 3. And then that's all over. And now we need to do x2 minus x1. And that is going to be 2 minus negative 1. Now, a minus is a plus. So this we can actually just change to plus, and we end up with, let's see, negative 5 over 3. So the slope of the line there, line L, is negative 5/3. You're always going to get a negative slope when the line goes down as you move from left to right. In the next example, when the line goes up, this is going to have a positive slope. Now, when you have a graph with like the grids drawn in, it's much easier to just count the rise over run ratios. So when we do rise over run, here's a little trick that I like to use. So for the rise, if it's positive, we go up, and if it's negative, we go down. And for the run, we are always going to run to the right. So that means when I start at my first point, I need to start at the point that's on the left so that we always go right. We never go left. So if I start right here at A, the rise is how many I have to go up to get to B. Well, I got to go up 1, 2 boxes. So that's the rise. So my rise over run is 2, and then the run is how many I have to move to the right. So 1, 2, 3, 4, 5, 6. So our slope is 2 over 6, and then we should simplify the ratio or simplify the fraction. 2 and 6 are both even numbers, so if we divide those by 2, we can simplify our slope to 1/3. Go ahead and try the try now on your own. Please pause the video. All right, you should have for your ratio 4 over 1. Now, when I look at my picture, it was up 8, and then we went over 2. Now, technically 8 divided by 2 is 4, but if I want to write it as a ratio, I need to keep it in fraction form, so I'm going to do 4 over 1. Now let's try a different type of problem. Suppose that the ratio of the side lengths of a quadrilateral, quadrilaterals have 4 sides, is 2 to 3 to 5 to 7, and its perimeter is 80. Well, first thing we're going to do here is if the ratio of the sides is 2 to 3 to 5 to 7, we're going to let 2x, 3x, 5x, and 7x represent the side lengths. Now we have to figure out what x is so that we have a perimeter of 85. Now remember, the perimeter is just the sum of the sides. So if you add all your sides up, they should add to 85. So in my problem here, I've got 2x plus 3x plus 5x plus 7x, so that's my 4 sides, has to total up to 85. And now you just do your algebra. These are all like terms, so we can go 2 plus 3 plus 5 plus 7, and that adds to 17x. So if 17x is equal to 85, do a quick divide by 17, and we get x equals 5. Now, the directions didn't ask us to solve for x. There's not even an x in this problem. We want to figure out what is the length of the longest side. Well, the longest side is the biggest of the ratios. So the longest side has to be 7x. Well, now if we plug in 7 times 5, that makes the longest side 35. And then since the perimeter is in feet, the longest side would also be in feet. For the try now, this one's a little bit different, so I am going to talk you through this one. If you want to pause and try it first, you may do that. This time, though, instead of perimeter, we're going to look at the ratio of the angle measures in a triangle. And is 1 to 6 to 13. So I'm going to, again, let the angles be 1x, 6x, and 13x. And we want to know what's the measure of each angle. Remember that in a triangle, the angles, the 3 angles, always add to 180 degrees. That's the triangle sum theorem. So to solve this question, we can go 1x plus 6x plus 13x equals 180. And now let's just combine our like terms there. That ends to 20x equals 180. We'll divide each side by 20 to get x equals 9. This time we want the measure of each angle, so I need all 3 of them. So I'm going to start with 1x. Well, 1x is just 1 times 9, so one of the angles is 9 degrees. 6x is going to be the 6 times 9, and that is 54 degrees. And then 13x is going to be 13 times 9, and that is 117. So the measure of each angle in the triangle is 9 degrees, 54 degrees, and 117 degrees. Next, we're going to move on to solving proportions. So we just talked about ratios and how to simplify and use ratios. Next, we're going to move into proportions. A proportion is just an equation that states that 2 ratios are equal. So a proportion is going to be in the form A over B equals C over D. And in a proportion, the cross product property tells us that if A over B is equal to C over D, then A times D is going to equal B times C. And you can either write multiplication with the parentheses, or if you'd rather, you can use the dot. A times D equals B times C. All right, so let's use that property now to solve some proportions. For the first one, I'm going to take 2 times 35, and that's going to be equal to the 5 times the n. So simplifying that, we would have 70 equals 5n. And then if we just divide by 5 on each side, that's 14. So n equals 14 is the answer to that first proportion. Let's try another one. In problem B, I'm again going to use my cross product property. So 2 times 32 equals, and then x times x. Now, an x times an x makes an x squared. I think you've seen that before in your algebra courses. If you haven't, just remember that x times x is x to the second power. It's 2 x's multiplied together. And if x to the second power is equal to 64, remember that we can undo a squared by taking a square root, just like we did with the Pythagorean theorem. So if I square root each side, the square root cancels out the squared, and we get 8. So x is equal to 8. And then if we check our answer, 8 times 8 is 64, and 2 times 32 is also 64. All right, one more here before the try now. This next one I have to be a little bit more careful for because there's not just a y, but there's a y minus 6. So when I do my cross product, y times 4 is just y times 4. But when we do the second part of the cross product, we need to make sure that we put a parentheses to keep the y minus 6 together. We have to take that whole thing multiplied by 5. So we're actually going to have to distribute here to get 5y minus 30. The other side we can just keep as 4y. And now remember, when we solve an algebra equation, we always want to get all the variables to the same side. So because the y is kind of already alone over on the left side, I'm going to actually move the 5y over. Even though it makes a negative number, this is going to be just one less step. So when we subtract 5y, it cancels over here, and we get negative 1y equals negative 30. Now let's just divide by negative 1. And remember that a negative divided by a negative makes a positive. So we're going to have y equals positive 30. Go ahead and pause your video now and do try now number 3. Please pause. Here's your solution to the try now. You should have gotten b equals 9. Let's look at this table here and show equivalent forms of the cross product property. So we're going to start back out with just this original proportion, a over b equals c over d, and there's a lot of different equivalent ways that we can write it. I'm going to show you 3 ways. The first way is just the cross product property, so we could write it as a times d. So a times d equals b times c. And if you want to put the dots in there, you can, but really AD means A times D, so we don't need the dots at all. Then another way that we could write it is we could take the original fractions and we could flip them. So, for example, A over B, I could change to B over A, and then C over D, I would also have to flip. So these are equivalent proportions. We'd still get the same answer. This one is flipping the fractions. And the first one, remember, was just your cross product property. All right, the other way you can do it is you can do like the numerator over the numerator. So like A over C and then B over D. And basically just kind of moving left to right, or numerator over numerator. Right, remember the numerator is the top of the fraction, equals, and then denominator divided by denominator. Denominator is the bottom of the fraction. So all of those are equivalent. So if we look at one with some actual numbers in here, let's look at 1/3. Well, the first form would be 1 times 6 equals 3 times 2. That's cross products. If we flip the fractions, we could go 3 over 1 equals 6 over 2. And if we go from left to right, 1 over 2, is going to be equal to 3/6. So those proportions are all equivalent and they all actually have the same cross product. If you look at these, 3 times 2, 6, 1 times 6, 6. 1 times 6 is 6, 2 times 3 is 6. All right, so let's go ahead and look at the next example here. And we're given 4x equals 10y, and we want to find a ratio x to y. So for this one, for a ratio of x to y, the 2 is the fraction bar. So x to y, I need the x to be at the top, and I need to get y to the denominator. So I'm going to keep that in mind here when I decide how I'm going to rearrange these things. So if I want to get y to the denominator, I need to divide by y. So now over here, I have the x over the y. Now we just need to get rid of the 4. See, this is the part that we want. I'm going to highlight that. X over y. So let's get rid of the 4 by dividing each side by 4. Because now when I do this, 4 divided by 4 makes 1. And I'm dividing each side by 4y, so I'm keeping it equal. So this side is x over y. Here the y over y's cancel. So we have x over y equals 10 over 4. So that is the ratio of x to y. Now, technically, you should always simplify your ratios. So 10 to 4 for a final answer, I would want to divide by 2 and say 5 to 2. So the ratio x to y is 5 to 2. Remember that you can also express it as 5:2. Or we could even express it as 5 to 2. So all of those are the same. Most of the time in geometry, the fraction is going to be the best form. All right, so the try now problem is similar to this one, but this time we want to get B to A. So I need B on the top, I need A on the bottom. To get A in the bottom, you're going to have to divide both sides by A. Let's have you pause the video now and see if you can finish this one so that when you're all done, you have B over A equals a number. Please pause your video. All right, there is your solution. The ratio of B to A is 4 over 5, or 4:5, or 4:5. Those are all the same. For our final problem today, we are going to look at a real-world application. So during the filming of The Lord of the Rings, the special effect team built a model of Sauron's tower with a height of 8 meters and a width of 6 meters. Okay, so the model has a height of 8 meters. So that's my height, and my width is 6 meters. So there's a ratio with the height to the width. And now let's see if the width of a full-size tower is 96 meters. So now we go to the full-size tower. So the width, I have to line up the width with the width of this one. So the width is going to be 996 meters. That's the width. We want to know what's the height. So how many meters is the height? That's my question mark. Now, as long as we line up like units, there's a lot of different ways that you could write the proportion. I did the model on the left and the tower on the right, but you could definitely do it a different way as well. And now let's just go ahead and do our cross products. So if we take 8 times 996, that's going to equal 6 times x. Grab your calculator and you'll get 7,968 equals 6x. Let's divide each side by 6. And when we do that, we get 1,328. Remember to include a unit in any real-world example. So the width of the full-size tower is going to be 1,328 meters. This concludes lesson 7.1. Thanks for watching and good luck as you practice some questions on your CYU.